Okay, this is problem 6 in section 9. So again, we're trying to take this function 1 over 2x. Actually, it's number 6. I don't know why I said 9. Number 6. So number 6 is f of x equals 4 over 5 minus x. And we want to center this around c equals -2. So what we're going to do is we just have x by itself, so what we want to do is rewrite this equation to fit the geometric series of this thing centered around c equals. So what we need is some number a minus x plus 2. And we choose 2 because we need x minus whatever this value. So you take minus and minus is plus. So what we need to do is then set 5 minus x equal to a minus x plus 2. And we're just going to set the constant parts equal to each other. So we get a is equal to 7. So the x, we get negative x and negative x on both sides. So that means that this function can be rewritten as 4 divided by a, which is 7, minus x plus 2. You can see we have 7 minus 2, which is 5, and then you get negative x. Okay. So now we need to get a 1 at this point, because it has to be 1 minus something. So we're going to divide, or multiply by 1/7 in both the numerator and the denominator. So that will give us 4/7 in the numerator. This will become 1, and this will become x plus 2 over 7. So now what we're trying to do is trying to fit into this thing a over 1 minus r. So a is 4/7, and r is equal to x plus 2 over 7. And it comes down to that 1 over, well, it's a over 1 minus r. Okay, try again here. So what we did is, when we have the geometric series that was represented by this, and it's from 0, is a r to the n. So that's the geometric series. So if we take this and we match it up, a goes here and r goes there. So all we have to do now is kind of we can rewrite this series as equal to the summation, well, not this series, but that expression. So a is 4/7, r is x plus 2 over 7, and you raise that to the nth power. And that should equal 4/7 over 1 minus x plus 2 over 7. Okay. And you can make some little modification to this, because I've got 7 here, and this is actually, yes, that's right. So we can kind of rearrange this. So you're going to have x plus 2 to the n, and then we have 4 here, and then we have 7 to the n, but we also have 7 to the first power, so it's 7 to the n plus 1 power. Now, as far as the interval of convergence, this series converges if r, the absolute value of r, is less than 1. So r is this thing. So r is x plus 2 over 7, absolute value. And then you multiply both sides by 7. So you get the absolute value of x plus 2 is less than 7. And then you rewrite this as the 3-part inequality like that. And then we subtract 2 from each term to get x in the middle. So we end up with that. So that's our interval of convergence. We don't have to worry about the endpoints because this was actually r is less than or equal to 1. So do we include it or not? Actually, let's look on the page on series, so the geometric series. So it converges if it is less than 1. So this is correct, not less than or equal to 1. So we just have less ends there. Okay, so that's number 6. So let's do number 12, I think is the next one. So let's go back and write that down. So 12, the function is equal to 4 over 3x plus 2, centered around x equals 2. So c is equal to 2. Okay, so again, what we're trying to do here is we're trying to get it to equal a over 1 minus r. That's how we want to get the form of f of x. So let's see how we can do that. So we're going to have 4 over 2 minus a negative 3x. So then what we could do is multiply the numerator and the denominator by half. That'll give us, actually it's not quite right. Okay, so yeah, what we need to do here is we need to rewrite this thing. So it's going to be negative 3 times, and let's set that equal to a. So we want to call it just some variable. So we have a minus 3 times x, and set around c equals 2, we need to put a negative 2 right there. So what we did is we need this equal to that. And that's because we have to x minus 2 to get the right centered thing. And so what do we got next? We got 4. Let me just make sure I'm doing this right before I... okay, I think I'm doing this right. Okay, so first we need to solve for a. So we say 2 minus 3x is equal to a times minus 3 times x, and this is minus 2, minus 2. Okay, so we take the coefficient part, so we get 2 is equal to a hang on with me here. Yeah, this is actually minus a minus 3x. So we can actually just leave this plus. Okay, so that's going to be plus here. This is still minus, so that's going to be minus 6. So a is equal to 8. Okay, so our function f of x can be written as 4 divided by 8 plus 3 times x minus 2. And now we need to divide the numerator and the denominator by 8. So you get 4 over 8, which is 1/2, divided by 1. 8 divided by 8 is 1. You get 3/8. 3 divided by 8 is 3/8. X minus 2. And so this is x minus r, so this is actually equal to negative r. So a is equal to 1/2, and negative r is equal to 3/8 x minus 2, so r is equal to negative 3/8 times x minus 2. Okay, so there's a and r. So once we do that, we plug that in from the result that for a geometric series, the result is this for the series summation from n equals 0 to infinity of a, which is 1/2, times this ratio, which is negative 3/8 times x minus 2 raised to the n power. So that's the series. And then we kind of have to clean this up. So what are we going to have? So we'll have x minus 2 to the n divided by 8 to the n. And we also have negative 1 to the n from that. And I guess you're also multiplied by, so you divide that by 2, and then you've still got 3 to the n there. Okay, so I think that's right. The book has a slightly different answer, but they didn't write this, they just kept this as negative 3 to the n. So they had negative 3 to the n. Okay, so now what we do is we have to, what is this part here is r. So r is equal to negative 3/8 x minus 2, and that has to be less than or equal to 1. The absolute value of this whole thing has to be less than 1. So we're going to multiply by 8/3. So that's going to be 8/3. Now the negative sign, because it's in the absolute value, we just ignore that. And so then we take this and make it into the inequality of 3 parts. So we have negative 8/3 and positive 8/3. And then we add 2 to everything. And 2 is 6/3, so this will be negative 2/3. This will be x. And that'll be 14/3. So that's my interval of convergence. So let's just circle that. So that's my interval of convergence. 8/3 is my radius of convergence. And the series is that. And let's just do one more. We'll do the next one. Actually, no, we'll do the next one, the separate one. It's a different kind of problem. So the next group of problems use a different result. So up to this point, we've used the geometric series, which says that we learned early on the summation from n equals 0 to infinity of a times r to the n was equal to a over 1 minus r. So they give us a new thing here that says, and I'm going to write it the other way, a different way than the book writes it. So we got that result. So it's kind of like R is like X, X is like R. So if we're given expressions here, and let's say this is not 1, it's 5, then you just bring this out. So let's just do that. Let's just show what would happen. So let's say you had negative 1 x to the a x to the n. That would be equal to a over 1 plus x, because you can factor that out. So if we have something other than 1 in the numerator, we just have to take this and multiply it by a. So the one I've chosen for you guys to do homework for is this one, 18. So we have that h of x is equal to x over x squared minus 1. And you can use partial fractions, and they do it for you here. It's 1 over 2 times 1 plus x minus or plus minus 1/2 1 minus x. And then we have to use this relationship to figure it out. So this kind of looks like that. So we got the 1/2 factor, that's the a. 1/2 times the summation from n equals 0 to infinity of 1 over 1 plus this. So that's going to be exactly that. So it's going to be negative 1 to the n times x to the n. So that's that part. Now the second part, I think that first one, you can use the first one, you can use this geometric series thing. So the second part is going to be negative 1/2. This is the negative 1/2 part. And then we get 1 over 1 minus x. So that's going to be equal to the summation from n equals 0 to infinity of r, which is just equal to x to the n, because a is actually a is 1/2 and r is just x. Now what would happen if I were to try to use this formula? I don't think I'm supposed to. You have negative, let's try it just for the heck of it. So let's say instead of you have x, you have negative x. So what we'd have for that part would be summation from n equals 0 to infinity of negative 1 to the n times negative x to the n. So I'm substituting negative x for x. But the thing is that, so it actually does work out either way, because what you'll end up with is the negative 1, well, let's write out one more term. So you can expand negative x to the n as negative 1 to the n times x to the n. And negative 1 to the n times negative 1 to the n is negative 1 to the 2n times x to the n. And negative 1 to an even power is just 1. So it just reduces down to x to the n, which is what I had here anyway. So originally I used the geometric series, but you can use this formula with negative x substituted. So let me see what they did. They don't really say, but I think what they are saying is that actually they simplify it a little bit. Okay, so they go a little further. So that part's correct. Then what they do is they add these two together. So what you end up with, well, you end up with this thing right here. So you take the 1/2 and you factor that out. And then you combine this with that. So you're going to have negative 1 to the n plus basically 1 to the n, if you wanted to do that, times x to the n. So is that what they did? They take negative 1 to the n minus 1. And I think what they did is they just show that, okay, that's interesting. Yeah, with this you wouldn't imagine this. So what we're going to do is we're going to do a couple of terms to see what happens. So when n equals 0, you get negative 1 to the 0 plus 1 to the 0, and that whole thing is times x to the 0. So that's n equals 0 term. Okay, then on to the next one. So you're going to have negative 1 to the 1 power plus 1 to the 1 power times x to the 1 power. Okay, do it again. Negative 1 squared plus 1 squared times x squared. Okay. When n equals 3, we get negative 1 cubed plus 1 cubed. Actually, we don't even have to do this 0 part. We just say it's add 1. Let me erase all that. So we just add 1. Keep adding 1 here. Don't have to change the x on it because that's not what's going on. So this is going to be plus 1, plus 1, plus 1, plus 1. So we'll get 1/2. We got to put a bracket here to match up that bracket. So we take 1/2, and the first term is going to be 1. Negative 1 to the 0 is 1. So you get 1 plus 1, which is 2, times x to the 0. X to the 0 is 1. So just get 2 for the first term here. Okay, the second term, you get negative 1 to the first part, which is negative 1 plus 1. So this part goes to 0. So the second term is 0. The third term is negative 1 squared, which is 1, plus 1, which is 2, times x squared. And the next term is going to be 0 again because I'm going to have negative 1 plus 1, which is 0. And so you kind of see what's happening. Then you have 2 times x to the 4th. So 2 times x to the 0, 2 times x to the 4th. And so this can be rewritten in a simpler form. Now, where did they get a negative sign from? Oh, it's because this is minus 1. I don't know why I did that. It's minus 1. Minus 1. So let me erase all that stuff. Okay, so what happens now? This actually goes to, the first term goes to 0. So this is negative 2 to the 0 times x to the 0, which is 1. Here we have negative, actually what am I doing? Negative 1 to the, so actually that's negative 1 to the 0 is 1, so you get 1 minus 1, which is 0. So we get 0 times x to the 0. And then we have negative 2, because we have a negative 1 to the 1, which is negative 1 minus 1 is negative 2. That's times x. And the next one is you're going to get 0 again, times x squared. And then we'll have negative 2 times x cubed plus 0 plus negative 2 times x to the 5th, and this works on so on. So we got this 2 times 2, there's a cancel out. 2 times a half is a cancel out. So we're just going to end up with negative x minus x cubed minus x to the 5th. So this series here can be written as negative because you've got this negative thing. And then you have the summation from n equals 0 to infinity of x to the, it's 2n plus 1. So when n equals 0, you get x to the first power. When n equals 1, you get 2 plus 1, which is 3. When n equals 2, you get 2n, which is 4, plus 1, which is 5. So that's the simplified version of this original thing. So let's kind of review what we did. Okay, so you have the original expression. You use partial fractions to break it up like that. They did that for you. This part we can use the new expression in the book to rewrite that as that. Here you can use either the one in the book or you can use the geometric series to come up with that. So that's what I'm doing here. I'm using the equation given on 674. That's why I did that. Okay, so now we take this and then we add them together, so you get negative 1 to the n, and then you've got a negative half. You get a half, so we factor that out. So you end up with a negative sign. So we get negative 1. And then we tried different values of n, and we found out that the even terms dropped out. So we're just left with this. So we factor out a negative sign, and you can rewrite x plus x cubed plus x to the 5th in that form. And that's the simplified version.